we want to complete the parametric equations of the line through the point 1, 6, negative 5 and perpendicular to the plane given by the equation 3x plus 8y minus z equals negative 2. We're looking at the point normal form of the equation of a plane that contains the point x sub 1, y sub 1, z sub 1 and has a normal vector n with components a, b, and c, which has an equation as we see here. Notice if we distribute the coefficients of x, y, and z would give us the components to a normal vector to the plane. And since our line is perpendicular to the plane, this normal vector would be a direction vector of the line, or the line would be parallel to this normal vector, which is all we need in order to find the equation of the line. A line parallel to a vector v with components a, b, and c passing through the point x sub 1, y sub 1, z sub 1 has the following parametric equations. Before we find our equations though, let's take a look at this graphically. We're given the equation of this yellow plane, and we're asked to find the parametric equations of the line that's perpendicular to the plane passing through this blue point. Well, looking at the normal vector here to the plane, notice how the line is parallel to this normal vector, and therefore we can use this normal vector and this point to find the equation of the line perpendicular to the plane. So going back to our problem, looking at the equation of the plane, we need to be able to recognize that this tells us a normal vector to the plane, vector n, would have an x component of 3, a y component of 8, and a z component of negative 1. And this is also the direction vector to the line perpendicular to the plane, or the line will be parallel to this vector. Which means looking at the parametric equations of our line, this tells us that a is equal to 3, b equals 8, and c equals negative 1. And because we're given our line passes through the point 1, 6, negative 5, this tells us that x sub 1 equals 1, y sub 1 equals 6, and z sub 1 equals 5. Notice for this problem they gave us the first equation for x of t. They gave us this so we knew exactly which normal vector to use as the vector that the line would be parallel to. Any scalar multiple of this vector n would also be a vector that the line would be parallel to. But because the coefficient of t is positive 3, we know this is the exact vector we want to use to find our equations. So again, we know that x of t, even though it's given, would be equal to x sub 1 plus a times t, which would be 1 plus 3 times t, or 3t. Y of t would be equal to y sub 1 plus b times t, which would be 6 plus 8t. And z of t would be equal to z sub 1 plus c times t, which would be negative 5 minus 1 times t, or just minus t. These parametric equations would give us the line perpendicular to the plane passing through the given point. Just remember, these parametric equations are not unique. Any scalar multiple of vector n would also give us a vector that's parallel to the line perpendicular to the plane passing through the given point. Again, we just found the parametric equations of the line in our graph here that's perpendicular to the plane passing through this blue point. I hope you found this helpful.